please spread the word and share it with your friends. All right, so I have been, I want to go to the next slide and it won't let me. Oops, there you go. All right, so it is beautiful here in Houghton. These are pictures from along my walk that I often take and before the time changes and it gets dark in the evening. So this is along Houghton Avenue, and this is where one of the ladies who owns the house, you can see, has planted a field of nasturtiums, I think they're called. It's absolutely spectacular, and we haven't had a frost yet. So, and these are some morning glories off on the left from my own yard. So I just want you to know how beautiful it is and how long a fall we've been having. And then this next slide, I'm showing you some mammoth sunflowers. So by mammoth, what I mean is the tallest of them is probably taller than 14 feet because I stood up next to it and I was nowhere near half its height. So we've had a tremendous growing season here, which has been awesome. So we had our first hockey game. We played Notre Dame. We tied it very close to the end of the third period at 1-1, and then we went into overtime where we lost and we were defeated with 5 seconds left on the clock. So we started the team. This was our first home game, and it was really fun to be there in person. So it's nice to be back in the stadium. So you're wondering probably why I'm in a strange place. I'm in a hotel room. That is actually the ceiling of my hotel room, which I've never had a hotel room with a ceiling like that. I'm staying in Columbus, Ohio, where I am at my first conference since things have come back, which is the MS&T conference. So I've actually registered. I'm attending the conference, and so what we did last night was we invited some alumni in the area to join us at a local restaurant. And this is Andy, who showed up in full Michigan Tech garb. And he had no problem recognizing us because we were all wearing gold and black too. But I just wanted our alumni to know that we, from time to time, have alumni gatherings in various cities, depending upon where I'm traveling or where other people are traveling. And so if you ever want to have an alumni gathering in your area, you should let me know by just dropping me an email. And so just to give a little bit more of a backstory, Andy wears this to games. He's on the staff at Ohio State University, and he wears this unashamedly to games and things. And he's always booed whenever he enters the room, but he doesn't care. All right. I'm having difficulty advancing. You can see I'm going backwards and forwards oh, there we go. I don't know what's going on here. One more slide. There we go. Oh. All right, I did it. Okay. As you can see, we're halfway through the season. Coming up next, the person speaking next week has been traded out, and I'll introduce that in a second on my last slide. I've never had this happen on this computer before, but I'm just going to go with it. So the next talk is about sustainability and resilience at Michigan Tech. The featured speaker will be Alan Turnquist, who is our new Director of Sustainability and Resilience at Michigan Tech. And the co-hosts are, as you can see there, and I'm really looking forward to that. And so with that, I'm going to stop share, which will stop my difficulty advancing the slides. And I'm going to introduce my co-host, who is Dr. Paul Sanders. And so there are several people who Dr. Sanders will be introducing in a second, but I'm going to introduce Paul first. Dr. Sanders has been a faculty member at Michigan Tech since 2009. He holds the Patrick Horvath Endowed Professorship of Material Science and Engineering. He's also one of our distinguished alum. He earned his Bachelor of Science in Metallurgy and Materials Engineering in '91. He then went on to get his PhD elsewhere. He's a Six Sigma Black Belt in engineering that he earned during his employment with Ford Motor Company. He has led the MSc Senior Design Program since 2010 and received 100% industry sponsorship for these team projects across the past decade. And these senior design teams have actually won first place for the ASM International Undergraduate Design Competition. the last 4 years and have placed the last 8 years. And that's a level of success unmatched by any other university in this international competition. He's also one of Michigan Tech's most prolific and creative researchers too. I have so much more to say about him, but I want to take up the whole webinar time lauding the credentials of Dr. Sanders. So Paul, I'm going to hand it over to you to introduce the rest of the participants.
Okay, thank you, Dean Callahan. So yeah, welcome to Husky Bites. We're excited to present some of the work that the students did. So the first thing I want to do is introduce the 2 students who are presenting, and then I'm going to introduce one of our collaborators. So first we have Sierra Braun from Stratford, Wisconsin. She graduated from Michigan Tech with a BS in civil engineering in built infrastructure and a minor in art. And she was the tiny house build team leader from spring 2020, which is when we started, through spring 2021. And her emphasis was on architecture and structural design. Now she's pursuing her master's degree in architecture from Lawrence Technological University, while also working as an architectural designer for SC Swiderski in Mosinee, Wisconsin. So SC Swiderski designs, builds, and manages apartment complexes throughout Wisconsin. And I think it's pretty cool that they manage them too. So I think that changes the design philosophy a little bit. And her career goal is to become a licensed architect and potentially start her own firm. So as I said, she graduated. Nick Kampschulte's still at Michigan Tech. He's originally from Grand Rapids, Michigan, and is planning to graduate in spring 2022 with a BS in environmental engineering. He's currently the team lead for the tiny house build team, and his focus is on production and implementation of thermal modeling. He's also designing a low-cost solar racking system with ground screw foundations. And that's part of our no concrete philosophy, which we'll talk about a little bit more, part of our green strategy. He's currently assisting in research on the deposition of anthropogenic nitrogen in lakes, and he's using radionuclide dating and stable isotope analysis in that process. And he's considering pursuing a degree in architecture after graduation as well. And then finally, we've got with us Dave Bach, and Dave Bach is a local designer who was involved in the project from the beginning. And Dave has been designing and building low energy homes using sustainable methods since 1979. He has 2 Michigan Tech degrees, a BS in mechanical engineering and a master's in ecology, with this knowledge being invaluable in the building site evaluation. Dave's father referred to him as an overeducated carpenter. So Dave has taught sustainable design at Michigan Tech, and Chris Wojcik, a former client and co-instructor of the Green Enterprise, which we'll talk about in a little bit, got him involved in the tiny house project. And he considers this project one of his most satisfying endeavors. So that's the introduction of the team. And now I think, Sierra, if you want to grab the screen, we'll get started.
And so let me just kind of point out that if people want to ask questions, the mechanism for doing that is to go to the Q&A feature down in the bottom right of your screen, and you just type your questions in, and we will answer them as best we can after the presentation.
Okay, thank you, Dean Callahan. So yeah, so we're going to talk about tiny house design, and I'll talk a little bit at the beginning, and then the students will carry most of the load. Okay, so we'll go to the next slide. How did this all get started? So the Green Enterprise is part of the Enterprise program at Michigan Tech, and it was established in 2008 as part of Tech's Carbon Neutral Academic Quality Improvement Program, AQUIP. So the Carbon Neutral AQUIP project seeks to improve the integration of sustainability into Michigan Tech's research and education. Under the AQUIP project, the Green Campus Enterprise is charged with estimating the university's carbon footprint and suggesting ways to reduce it. And this, I think, flows very well into the next Husky Bites topic. Chris Wojcik has been involved with the Green Enterprise from the beginning and has been the advisor of the Green Enterprise until he retired at the end of 2020. So a little bit of background on how this got started. There's a company called Phoenix House, which is a Colorado tiny house builder which expressed interest in partnering with the Michigan Tech Enterprise Program on a tiny house design. And this happened in the fall of 2019. This seemed like a fit to the Green Enterprise, and Chris and Dave were involved in developing the project. However, the scope shifted towards wiring interfaces, and the Green Enterprise was not interested. So in parallel, I learned of the tiny house project and was looking for help on solar electricity installation. And I connected with Chris and Dave, and at first I was the backup option, but as the project scope crept away from the Green Enterprise, I morphed into the primary option, as I was open to the team doing the design and building. And that was what Chris and Dave had initially envisioned. So that's how we got started. And after the project got scoped, or while it was being scoped, Chris sent out an email to a bunch of students who may have had interest in being part of this team. And I think he got 22 applications. And on the next slide, we'll show you the 6 people who were accepted and worked through the project period. Okay, so this is the slide that shows the team, and Sierra and Nick have already been introduced, and the rest of the team is Carolyn, Lexi, John, and Lena. And they're not here, but they also contributed to the project, and you'll see their pictures later on when we show the build. Okay. Here, but they also contributed to the project, and you'll see their pictures later on when we show the build. Okay, I don't know why I got repeated there. They also contributed to the project, and you'll see.
Let's all hit mute except for Paul right now.
Okay, so as Dean Callahan said, I'm the Patrick Horvath Professor of Material Science and Engineering, and on the lower right, you see the location of the project, which is on Bay de Gris up in the Keweenaw Peninsula. And there's a couple pictures here where you can see Mount Houghton and Bear Bluff. And what we just substituted a picture of the actual property from Google Maps. So you can see it's a wooded property right on the bay with a sand beach, quite a find actually on the Keweenaw. And what you'll see though in the next picture is it's quite a difficult building site. And the reason it's difficult is that about 75% of the property is classified as wetland by the state of Michigan. And in addition to that, there's a 25-foot setback from the road and a 75-foot setback from the lake, which you can't really do much in. So that left a little triangle in the upper left where we could put a house, put a drain field, and all that kind of stuff. So that's why we ended up at a tiny house, is we had a tiny build site. And so we were able to make it work. We had to get a permit to put the driveway in through the wetlands. And then the team got busy on picking the footprint of the house and designing the inside and the outside. Okay, so next slide. Okay, so this is our first poll question.
This is a great question. I have no idea what the answer is.
Well, I tried to be creative in some of those answers. Okay,
I'm going to go with Gray Beast.
Yep.
So the choices are, I'll read these out: Betty Grease, Gray Beast, Green Bay, or East is Better. And there's a live poll going on, and people, the top 2 choices seem to be Gray Beast or Green Bay, which and the order, notice alumni, anyway, this is hilarious. Tell us the answer, Paul.
Okay, so the answer is actually Gray Beast. So good job. The majority or the plurality of people got that right. Okay, so let's move on to the next slide then.
And so if you have this in front of you and you don't want to see it anymore, just hit the X on the poll question and the little box will go away.
Okay, so Dave, do you want to take this slide? Oops, we can't hear you.
Unmute.
I'm unmuted. So the design goals here are to build use sustainable design to build the building. And we had a couple other chief parts of that, and one was net zero energy. In other words, we wanted to produce as much energy on site as we would use on site. And we use the source method, and I'll go into more detail on that later. And for the renewable solar energy part of it, we're going to use photovoltaic panels. And those will not be mounted on the house. They'll be mounted on the ground in a site that has better solar access. And we determine solar access on this site by using a reflective machine that allows you to look at the trees, then outline the trees and figure out what percent of shading you hit. Energy efficient was a big part of it, and I helped a lot with that because that's part of my business. Passive house concepts. Passive, and we'll go into more on the passive house concepts, but let me say that the passive, when we talk about passive house concepts here, we're talking about a variation of the passive house program from Germany. Not passive design strategies, which is something else. So we're going to use the passive house concepts, although we're not going to meet the metrics of the passive house design. We're going to use their software, which is very good. And we're going to try to get net zero energy metrics. And we're going to use sustainable material selection as well. That is as important as being energy efficient and net zero energy.
Okay, and since I'm in material science and engineering, I should have my token material slide in this deck. So our strategy with sustainable materials was pretty simple at the high level. First of all, we wanted to avoid concrete because concrete contributes globally 8% of greenhouse gases. We used wood, renewable material, but also whatever we build into the structure, we sequester the carbon there. As a metallurgist, I'm partial to steel. And one of the reasons we like steel for an exterior is that it's maintenance free, essentially for the life of the building, but it's also typically about 50% recycled, one of the most recycled materials that we use. And finally, we used green insulation. So this is just an example of some of the charts that we looked at to try to make our material decisions. So fiberglass insulation was used to minimize the carbon impact. Okay, and then Dave's got a couple slides here on net zero energy.
Yes, net zero energy by the source method. As we worked through this as the team, this was hard for us to get our heads around at first. So when we talk about the source method, what we're talking about here is all the energy that went into making the energy that comes into the house. Say we're looking at electricity and coal is going to be the power plant. So we're looking at all the energy that would go from extraction of the coal through the steam generators, transmission lines to the plug at the house. And the source energy conversion factor for electricity, if you look there to the left, is 3.15. So what we're saying here is that for every 1 bit of energy we get at the house, it took 3.15 units of energy to produce that. So electricity is about 33% efficient at the plug. The other fuel that we used on this project was propane or LP. And here you can see that the conversion factor is smaller. In other words, there's less embodied energy in making propane than there is in electricity. So our goal here is for all the electricity and propane we consume on site to be equal or less than the production we would have on site. And this is where it gets a little bit tricky because we multiply the amount of electricity we would use. And in this example, it's only an example, say we have 100,000 kBTUs, K equals 1,000 BTUs of energy demand. We multiply that by 3.15, we come up with 3.15 kBTU of electricity, propane 1.15. Add those together and divide by 3.15. Now, why are we dividing by 3.15? That's the part that it's hard to get your head around. So what we can say here, and I think Sierra figured it out best, is that the electricity that we put back into the grid is considered usable by somebody else without having to go through the whole process of burning coal to get it. And therefore, we can divide our energy input by 3.15, and that is the amount of energy we have to export back to the grid to make it equal.
Yeah, good.
So here is a little bit more about the passive house concepts that we use. Let's start in the upper left-hand corner. No thermal bridges. Let's talk about a 2x6 wall, a standard 2x4 or 2x6 wall, if you're familiar with that from residential construction. The 2x4 goes through the wall from outside to inside. Wood is a fairly good insulator, but not as good as fiberglass or the material in the cavity. Therefore, we consider the 2x4, 2x6, a thermal bridge. And we would like to have a thermal break on that bridge. You can really cut down on your energy use if you separate the conductive components from the outside. We used a double stud wall. So just imagine two frame walls spaced apart. So you can see there's very little conduction of heat through the framing. Now the thermal envelope, the part that goes around, that separates us from the outside, the habitants from the outside. We were able to build walls that were at least an R30 and a roof of at least R60 and a floor of at least R30. Those were our goals, and we met all those goals plus. The other part that is important is to make the envelope airtight. This controls heat loss through wind blowing through the building, basically. And it also helps maintain indoor air quality because now we have control of the indoor air quality. And to do that, once you've tightened the house up that much, you're going to have some mechanical ventilation system here. And what we use is a heat recovery ventilator. In other words, the fresh air that's coming into the building is preheated through a heat exchanger by the stale air leaving the building at 60 to 70% efficiency. Some of the more expensive units, even up to 90% efficient. The air tightness of the envelope, we're striving for what would be natural air changes of less than 0.1 air changes per hour. In other words, the building sealed up without the air exchanger going, you would have less than 0.1 times air changes every hour. A tenth of the air in the building would be exchanged every hour. And then, of course, there's glazing. Glass is the least energy efficient part of the envelope. So you have to balance your glass, in other words, the heat loss or gain from the glass, with other great qualities of glass, which is light and ventilation and view. And those have to be balanced out. And we use energy modeling program to do that.
So here's our second poll. Was Paul looking for a net zero energy house? Yes or no? I know I sort of gave it away earlier. Just seeing if you were listening.
Dave, I got to have you come take a look at my house. You can hear the wind blowing through it.
Yeah, did the curtains move?
Yes.
Yeah.
I think it's like R minus 10 or something like that. I don't know. It's some sort of bad number. All right.
Okay, so we're not doing real well on this question. No, I wasn't looking for a net zero energy house. Dave and the students and Chris were seeking to build one, I think, and I got one. So I'm thankful for that, but it wasn't my original intention. So yeah, thanks for that poll, and remember to click the red X to get rid of it. And then we'll move on to the next slide, which I think we're going to hear from Sierra now, right?
Yeah, for sure. So in the beginning, I remember doing a lot of research to fully understand everything that Dave just talked about. And to cover it all, our team was split into 3 kind of collaborative groups. Myself and Nick were on the structures team, and we focused on making the building stand up. So we were super responsible for determining the house layout, as well as designing the construction assemblies that Dave touched on, and calculating the loads of the different beams and joists in the house. We also had a mechanical team who worked with our proposed wall assemblies to determine ventilation and heating equipment to be used in the house, and a team that focused on getting power, water, and electricity while aiming for those net zero energy goals. Another aspect of this project that's still in the works is the solar array system and a home performance monitoring system that Nick is diving into this semester. And like Dave said, we used a bunch of different software packages, both from Passive House and some that Dave designed himself to make it all work. To show some of our progress through the spring of 2020, I added some of our early design ideas for the tiny house so you can see how much it morphed over the semester in our design phase. Like I said, the learning curve was really steep in the beginning. All of us were trying to pack our brains with knowledge from Dave while learning the different design programs for drafting and energy modeling. And we were trying to make sure we were meeting everything Paul wanted in his tiny house for his family. So from these early renders, you can really see how the house has evolved, especially in terms of roof design, layout, and exterior appearance. You'll see the bathroom moves around a lot, the roof changes, and all of these were in consideration of where the solar array was going to be placed, as well as getting the best views and performance monitoring. So each iteration of these houses we modeled in the different design packages to determine which one was going to perform the best for our goals. So yeah. Another thing we had to figure out was how to break this house apart into sections or panels so that we could build them on campus. Now I'll move on to the final design. So like Paul showed earlier, this is the same diagram from there. His lake property is on a wooded shoreline with a bunch of wetlands. So here's the building area again, very small, really basically only a tiny house could work. So it was perfect for us. The high water table also gave us some challenges with the driveway and required an engineered septic system and shallow foundations. If you look at the site render, you can see the viewing window to the northeast towards Bear Bluff and Mount Houghton. And in placing the house and solar array, we really aim to reduce tree removal by utilizing the naturally open areas wherever possible. Looks like we've got another poll question here. What is legend of sound heard on Bay Degree?
Yeah, so what is the legend? So the choices are voice from a Native American who lost her lover on the Great Lakes. The sand sings by pressing it with your hand. The sand barks when struck. The sand loses sound when removed from the beach. I guess I really skipped my articles there. Sorry about that. I need about 3 thes in there.
You did good, Paul.
Well, it looks like overwhelmingly people are going with the voice from Native American who lost her lover on the Great Lakes.
Yeah, so the answer is actually all of these, but the origin of the legend is this voice from the Native American. And then the idea is that the sand sings by pressing with your hand or when you strike it, and that actually helps this Native American woman call her lover back. And I guess the legend is also that if you remove the sand from Bay de Gris, it doesn't make the noise anymore.
Oh,
Yeah. Okay, so thanks for that poll, and we'll carry on.
Cool. So yeah, our final design on the exterior had a lot to do with the solar array placement. We had originally considered placing it on the roof, but we turned away from that in keeping as many windows and as much headroom in the loft as possible. So in determining the exterior look, a lot of it also came down to material selection. Steel siding and roofing was picked, like Paul said, for its long-lasting durability, high recyclability, and low maintenance. And of course, Paul was interested in the metallurgist vibe. As far as the interior, we kind of unanimously picked this floor plan. It's packed into a 12 by 20 footprint with 180 square feet of heated space on both the main floor and the loft. In the floor plan render on the right, you can see the bathroom and kitchen to the south, and the living room and dining area are left open to the views. The open ladder leads up to the loft where there's sleeping space for 4 and a mechanical closet. And it still has headroom to stand up in the loft, which was a big criteria for Paul. He's a tall guy.
7 feet on the tall side.
So as I mentioned earlier, a ton of thought went into the construction assemblies to help us meet the high standards we set for the tiny house. So I'll just highlight the ones here, which Dave already kind of touched on. For the walls, we used 2 2x4 stud walls spaced apart to provide that thermal bridge or thermal break and a deep insulation cavity. Though they weren't the thinnest option, we decided that the availability and cost effectiveness of wood and high R fiberglass were more advantageous than some other more novel new products. For the roof design, we stuck with wood frame construction, but stacked 2x12s and 2x4s with insulation between them to keep that thermal break. It also allowed us to have a thick roof assembly at nearly R60 while maintaining a thinner profile from the outside. And for window selection, we ended up with triple paned glass. It's filled with argon, and they also have insulated fiberglass frames, which is a pretty unique product, I guess you could say. So they'll be high R, as high about R value as possible for windows. And we carefully placed where they were able to be operated, so where you could open the windows for ventilation, and also looked into the glazing type we used depending on the wall that the window was placed in for passive solar gain. And to align with our goal of no concrete, the whole house sits above the water table on a shallow wood frame foundation with gravel trench footings. Another key point about using conventional building materials was that it allowed our team to quickly jump into on-campus production of the wall panels, which we'll get into after Nick's digital tiny house walkthrough here.
Yeah, let's see if this works. Oh, seems to be going pretty well. So this is we're kind of flying by the exterior of the house, and I put in some trees to kind of help get you in the mindset of being on Bay de Gris. So here we're coming in on the back, and the site is much more heavily wooded than this, but I wanted you guys to be able to see the house pretty well. So now we're zooming into the house through the front door and getting a nice look at the kitchen area, into the living area, and this is the bathroom here. It's a little fast. I'm admittedly not great at these 3D walkthroughs. And there's the kitchen, and we're going to head up to the loft. And the loft, you can see we have a lot of sleeping space, so 2 queen beds up there. And excuse the fact that it's a little see-through. I was having an issue with the software. Couldn't really remedy that issue, but now we're flying out the egress window, and there's the scene from Bay de Gris right there. All right.
Looks good.
Oh, that was
Nicely
fun.
done, Nick.
That was really fun.
Thank you.
Nicely done, Nick.
So I believe we got another poll here. So could this project produce 2 architecture students?
I vote yes. And their names are Nick and Sierra.
You might be right.
About Sierra, but I didn't know about Nick till he prepared his bio for this event. Yeah, okay, good. So we got yes, 94%. That's the right answer. A plus.
Guess there's your decision, Nick.
There we go. That takes a lot of guesswork out of it for me. All right, so Sierra touched on, we built this building in panels on campus. And so how do you get a ton of engineers, a lot of which haven't held a hammer before, to build a house? And part of the answer to that is Chris Wojcik. So he really stuck his neck out for us and got us this lab space on campus, really prime location to receive lumber shipments. And in there we had three kind of teams working at all times. We had a management, sawing, and framing team. And the management team would organize meetings, keep track of our COVID log, and also work with sanitizing. And then sawing people were in charge of using the bill of materials and construction drawings to cut out all of the lumber that was needed, and then they would send it over to the framing people, who would interpret the drawings, put them where they had to go, and confirm dimensions when assembly was complete. So this next photo on the next slide, there's us standing proudly over one of our first foundation walls. That's about 8 by just shy of 3 feet. And that's all foundation grade lumber, because that's what the house is sitting on, is that shallow trench. And that's the whole team. I think one of the last times, or the last semester, we were all together. So this next slide kind of goes in more depth on the foundation walls. Foundation grade lumber for longevity and rot resistance. And then that picture on the left, you can see we kind of mock assembled the foundation in the lab. We had pretty great neighbors in the lab. They put up with all of our shenanigans building a house in there, wall by wall. But here we checked the overall dimensions to make sure when Paul got on site, there wouldn't be any head scratching. So this, after we built the house from the bottom up, so after the foundation, we moved on to the main loft walls. And here you can see, I think I'm in both of these. We're working on the double stud walls, and conveniently enough, the spacing was such that we could put a 2x4 in between them and nail them all together. So there's Lexi and I working on one of those. And we actually had to push it, the double stud wall, up against a post in the lab to be able to hammer on it, because the floor was just so slippery. And moving on to the next slide, you can see Paul here. I gotta play this guy in Tetris sometimes. he got a lot of these panels onto such a little trailer. He said it pulled great down the road up the Bay Degree. I don't think I would pull it, but more power to him.
4 loads total to get the foundation, the first floor, and most of the second floor out to site.
Oh, wow. So this summer, Paul went to work putting that foundation in, and she did a great job. That's the picture on the right. They're up on the site. They got the gravel footings in there. And moving on to the next slide, we have more on-site construction. So picture on the left, you get to kind of see what Paul will be seeing when he's sitting back at the end of all this at his kitchen table. A nice view of Bay Degree. And then on the right, we have a picture of one of our design choices to leave the floor joists for the loft exposed to kind of both make it a little more rustic and then also provide more headroom, because I'm a tall guy and those are the little things that I appreciate. I know Paul will too. And then next slide, we have more joist pictures. So our rafter design was a composite design. I know we spent a lot of time on that to meet the snow loads for this area, and a potential, we had gone back and forth between, do we put solar on the roof, do we put it on that? So we always erred on the side of caution and overbuilt when we could. And that picture on the right, you can see one of the more recent pictures of the house. All the air, roof, all the barriers are on. So that's that thermal envelope that Dave was kind of talking about earlier. That everything in there is sealed now. On the right, you can see he got started on that metal siding that we were talking about. So moving on, how do we know if this is all worth it? How do we know if we met these pretty rigorous standards that we set out for ourselves? And so the first thing we can do is to check our construction process using a blower door and a flow hood. And what those measure is the air tightness of the building, if we kept that thermal envelope sealed, and then the flow hood measures ventilation, because as Dave was saying, with a building so sealed up, you really need to be cautious with your ventilation to make sure that's squared away. And to make sure we hit our thermal targets, I'm working on the thermal sensing system, and there are commercial options available, but we're doing it the tech way, making it ourselves. And this is a Arduino-based, cost-effective, using pretty cheap sensors that are also highly reliable. And so the plan is to, actually, we'll get into that later, but if we can gather enough thermal data, here's just an example of what we're hoping to get of how temperatures change throughout the seasons, throughout the days. We can calculate the R values of the walls given our measured values and then see if we hit our target. And another thing that Dave led me onto was that there's not a whole lot of data out there about how moisture travels through a wall assembly. So we're hoping to gain more insight on that by using combined temperature and humidity sensors. So this next slide is a little more in depth of what this monitoring system will look like. Excuse the sketches, is not to scale. So here we have the wall assembly. And you can see all the insulation in there, and you have the interior and exterior siding. So the plan is to put sensors at 3 different depths in the wall to measure the temperature gradient throughout the wall. And all that processing will be done by an Arduino microcontroller and upload that data to an SD card. So it can be taken out of the house, plugged into a computer, and we can get to work on data analysis. So we're going to compare what values we get from the house to the values that we got in our thermal modeling passive house programs. And then using this data, we can also kind of calculate, sorry, Sierra, calculate predictive energy consumption and kind of put together a report for Paul, so what he can expect to spend on the house throughout the years, heating it and so forth. So moving on to our last slide, we all had some positive impacts from this, and you can see Sierra and I kind of got bit by the architecture bug, and hopefully you guys will too after watching this presentation. So for me, the biggest impact is came in as an environmental engineer, still love it, but I'm considering pursuing a master's in architecture now because of it.
Yeah,
But
and for me, my focus is just trying to get this thing weather tight before the snow flies. I've learned a lot, had a great time, but I got this singular focus right now, besides showing up for work, is to get my tiny house closed up. Sorry, Sierra, what were you going to say?
I was just going to say that it's really prepared me well for my job in architecture as an architectural designer right now, as I do my master's in architecture and look towards getting my license someday. So really awesome project to be a part of.
Yeah, I agree with Sierra.
Great job, everybody. Absolutely terrific. And so I just want to, we will take questions now. I want to remind people they can load questions in the Q&A feature. People have already loaded some, and I'm going to kind of pick one out right away. One first from John Sawyering and then one from Bob Carnahan. So John asks, are any tiny, John asks about, was the use of geothermal considered for this tiny house? The water table being so close to the surface would minimize upfront costs.
Yes, I'm a geothermal geek, and I do have plans to bury some tubing right in the water table for a couple reasons. One, maybe to supplement the heating in the house, but also one of the concerns about having solar panels in the Keweenaw in the winter is that pesky snow gets on top of the panels and blocks the power generation. So I've got this idea, which a lot of people don't think it's possible, but maybe using some geothermal to melt the snow. And then one other interesting thing we're doing is we're going to have bifacial solar panels. So the idea is that light will reflect off the snow or off the lake, and we can generate electricity from the light hitting the panel from below. So hopefully that'll provide a little heat too.
Well, and there's lots and lots of questions out there, and this is always difficult to choose what to answer, but Bob Carnahan wanted to know, are any tiny homes being built in our area? But, I mean, of course this one is, but does anybody know of any others?
Well, I do know that this is the only tiny house being built in Keweenaw County, or at least permitted tiny house. I don't know, Dave, do you know any more broadly? Is anybody else building? I mean, we're on a foundation because we have to be, because the county wouldn't let you keep anything on a trailer there longer than 60 days, which is not quite long enough. But I don't know if there's any trailering or foundation-based tiny houses other than that.
I know there was a student who built a tiny house and lived in it. But I think she graduated before this project started. And of course, there's also an enterprise that is going to use an old fraternity site along US 41. And they're going to have, their idea there is to have a major community house and then have a number of tiny houses on the property.
Okay, so good answer. Dave, I got a question for you from Carrie Irons. Given that R values are like sunscreen SPF with significant diminishing returns beyond a certain point, what are the economics of the added R value above 25 in walls, 40 in ceiling at various costs of energy levels?
Yeah, that's a good question. The answer that I'm starting to come up with is when I first started this, we started with 2x6 walls and we used styrofoam on the outside. And we thought we were making the high performance building. That now is code. The 2011, 2021 model energy code for the United States for zone 7 where we live will be the equivalent of the R value of a double wall. That will be the new code. So it's a hard question to ask because we are realizing that energy use is becoming more and more important. We want to get away from the non-renewables. So the codes are sort of pushing us to higher and higher R values. I don't know if that answers the question well, but there's a lot that goes into deciding if it's cost effective or not. I'll say this for the customers that I have, when I first started building, we talked about the cost of insulation and the cost of the fuels and everything. And my feedback from those people were never about the energy. It was always about how comfortable the houses were, how draft free they were, how the kids could crawl around on the floor. And I started to see there were other values to these kind of houses other than just saving energy.
Yeah, good point. Yeah, Dave had to remind me that I didn't have to worry about the heat all collecting at the highest point in the house anymore because it's insulated all the way around and there wouldn't be all those drafts. So Nick, there's a question. Is there any planning done for automation or sensors for heating and other devices / appliances to reduce electricity usage or improve the efficiency?
Yeah, so I was actually just typing out a response for that. So, so we're working with another PhD student who has a kind of, he designed a low-cost electrical sensor, so we can put that in all the circuits in the home and monitor what circuits are using electricity and kind of dial in that, oh, that circuit shouldn't be hot right now, or we can kind of dial in when the heating unit will go on and off. And we're hoping to learn from the thermal sensors what the heating requirements of the house are. So if, say, like, if the crawl space needs to be heated, or if the building is insulated enough to the point where we don't need to worry about pipes bursting in there, or if the sunlight, the natural light gain that we get is enough to keep the house warm enough when people aren't there. So when we have to have the heat on, and how, I guess, how the house behaves when no one's there, we're hoping to learn.
Well, and we try to answer them all verbally if possible, instead of typing the questions. But
Okay, sorry.
There's a lot of questions, Paul. Like, are you going to live there?
Yeah, well, I'm trying to get Sierra and Nick involved. So I'm going to go with this question next for Sierra. For the door and the need to minimize air exchanges, was there any consideration of adding a mudroom, a bump out with an exterior door and interior door for the tiny house design?
No, we did not consider that. I guess it never really occurred to me, to be honest. A big part of the airtight envelope is also the amount of surface area you are allowing the space to have. So like if it was an unheated, unconditioned mudroom, which I think is the assumption, then that would have minor benefits because the air going in, you'd still obviously lose whatever unconditioned air is in that mudroom. But if it was also a conditioned space, you have additional seams and it might be harder to get that R value or the air tightness goals that we're looking for. So I'm not sure. Dave, do you have any other thoughts on that?
Yes, when I started building houses, we always had an airlock on the house. Didn't take long to realize, and we partially heated the space because of course we're trying to cut down on the heating load of the house. So we didn't want to really heat this airlock. So what happened in the airlock is the moist air from the house would go in the airlock and condense. And we were starting to have trouble with rusting of the doorknobs, mold on the drywall and so forth. So I've eliminated them just simply because they became a durability problem. Unless you heat it, then it's part of the heating load. And if it's unheated, it's an airlock, right? But when you open the door, the air comes in there, and when you open the other door, it goes in the building. So
Yeah. Yep.
I
Good.
hope that answered the question.
Yeah, that's a good answer. Okay, so we have a question from Bruce Cuffer. How much does typical snow loads have? What influence does that have on your structural and other design parts of the tiny house? Sarah, you want to start with that?
Sure. So snow load for Keweenaw County is 100 pounds per square foot. So like in my area at home, central Wisconsin, it's only, I believe, 30 or 40 pounds per square foot. So obviously we had to size our rafters and the roof accordingly, and then all the loads that as they transfer down to the soil. So it was all calculated process with a lot of help from Dave, because he's been building in the area for a long time.
So one of the fun facts about the site location is we are in the so-called banana belt, and it's hard to believe there's a banana belt in the UP. But anyway, along the eastern shore, there's not a lot of snow actually, at least for the Keweenaw, that falls because most of it comes out as it goes over Brockway and that ridge. So believe it or not, the snow load in the region we built in is only between 100 and 150 inches over the last 10 years. So that's not as high as you'd think if you were a little higher elevation. Okay, so here we've got a question from John Soyring. As natural fibers have a much smaller carbon footprint than fiberglass, why use fiberglass rather than natural fiber insulation? Sierra, Dave, do you want to take that?
Sure. A lot of it came down to availability of materials. For a while, we had talked about using mineral wool insulation. Not necessarily, I guess it's a natural fiber, but it's a kind of a byproduct of, what is it, Dave? I can't remember the term.
Flag.
Yes. So based on how limited our supply of that was in the UP and our, want to support local companies, we went with fiberglass. It has a similar R value as those other options, but the cost effectiveness was better. It was easier to get. So that's why we went that route.
Okay, good. Let's see. Got a question from Eric Peterson. I thought I heard someone mention tubular foundations. In railroad signal construction, we have used auger foundations for signals and support platforms for signal equipment houses. I can help with contacts if needed. They could be easily put below the frost line. So Nick, we've been talking about this lately. You want to talk about that a little bit?
Yeah, so no concrete. So the plan is to mount the solar racking on the beach front. There's kind of a big white pine that was there. It fell over in a windstorm and made a nice natural spot for us to put our solar. And so we're looking at ground screws to use it just to get away from concrete. And funny for those that remember, but when we first started the project, Paul had talked about using ground screws as the foundation for the actual house before we kind of went to the gravel. But anyway, so we're sizing it. We're more worried about the wind load than we are the snow load, the wind picking these panels off the ground, because the array is destined to grow at some point as Paul gets more time and money and wants to go further off the grid. So we're trying to size it such that when he adds panels, the appropriate amount of ground screws are added, just so that we're not building a wing essentially on his beach. Something that'll end up from on his beach, then in his driveway. We want to avoid that at all costs. But the issue we're running into right now is that the bedrock is pretty shallow, so we're kind of limited as to how long ground screws we can run. And we're actually looking at boring into the bedrock to run longer ground screws, or kind of like concrete bedrock anchors to secure it as well.
Yeah, so a couple interesting things Nick brought up. At the house, the bedrock is only about 5 feet below the house foundation. So when I was trying to put the ground rods in for the electricity, they're 8 feet long, and I would have 3 feet of them sticking out of the ground. So I had to put them in at an angle. So the bedrock's pretty close. And then as Nick said too, we had the unfortunate November gales come in and knock down 2 sort of landmark pine trees, which basically took out everything below them too. So that's where we eventually decided to put the solar. And Dave was talking about the solar mapping or tracking that we did to find the space. Well, once you knock down all the trees, it's pretty easy to find the sun. Okay, let's see. I got a question about, is there a concern from Art Rathke? Is there a concern about critters digging under the foundation? First of all, they'll have to be amphibious, because the water table's right under the foundation. But I don't think right now we're concerned about that. The gravel's what, a foot thick or something like that. And it's got fill over it now. So it's maybe 3 feet below the surface. So I guess there's a lot of quick things I can answer here. So I'm gonna just go through some of them. Let's see.
Water supply. You have a well?
Okay, yeah, so there's going to be a well. It's going to be 50 feet away from the septic tank, which just got put in 2 weeks ago. And then it's going to run, the pipes are going to run underground to a pipe that we already put in underneath the foundation to bring it into the crawl space. So we'll have our well tank in the crawl space, and we anticipate that area, since it'll be insulated, won't freeze. Is anybody gonna live in this tiny house all year? So I hope so. Yeah, somebody just is unmuted here. I hope that we can live there all year, but we're not going to do that right away. We also hope to have friends and family and friends of the department and everything come up and use this. Of course, it's very close to Mount Bohemia, so we figure that there'll be some people who want to ski and stay there. So we're hoping to keep it open all year round. We hope it doesn't take a lot of heat to keep it from freezing, and we hope we use that as much as possible. Okay, so there's a question from Frank Zapek, maybe is how you say his name. Any consideration for solar heating for hot water? Would it save on propane? So I did a little project with Professor Pierce, who was into solar energy, and we did some efficiency calculations of whether you're better off using your space for photovoltaics or for water heating. And the theoretical analysis says you're much more efficient if you use photovoltaics and generate electricity rather than trying to heat water. But Dave and anybody else, do you have any experience about hot water systems, solar hot water systems versus photovoltaics?
I've done some analysis too. I came to the same conclusion you have, Paul.
Okay, good. Thank goodness. I hope I did.
Yeah, electric resistance heating is pretty efficient. PV prices are going down. Solar thermal is fairly complicated. I had solar thermal on my house for about 14 years. Worked great from April to till the snow started flying. It's a good system. It works really good. It's just that with PV prices dropping and the efficiency of resistance heating, my calculations came out the same as you guys.
Yeah, so here's one for Sierra. Did you have the upstairs egress on the same side as the door? Have the fire codes been considered?
That's a good question. We do have it on the same side as the door. That was switched later on, just as more of a escape route when we added the front porch that we saw in the digital walkthrough. However, I'm not sure. I believe the fire codes are kind of addressed within the IBC, and there was no location specified. Dave, do you know any more on that?
Yeah, I believe you're right, Sierra. In this case, we just, because we're more than 6 feet, because it's a bedroom area, we needed an egress, and it's one room. So we need one egress, and it doesn't specify what side, that it has to be opposite the door or anything. As a matter of fact, we like the idea of putting it over the porch roof so that you could crawl out of the egress window, get on the porch roof, and get down to the ground.
Yeah, and it is an egress sized window, that one. We actually had to make it a little bigger. And from my perspective, one thing we forgot is to update the drawing. So when I went to put that window in, my framed opening was 2 inches too small. But thankfully I screwed those studs in place. So I just unscrewed them, cut the plywood a little bit, and was able to put the window in.
Welcome to the construction world, Paul.
Yeah, that's right. So a question from Greg, any on-site energy storage or grid tied only? So right now we have an interconnection agreement with UPCO to put power back on the grid. And we're fortunate to have that agreement because we got some inside information that almost all the agreements that were available were taken. So I guess there's a limit on this, and UPCO won't put any more on because they're not a big fan of these agreements. But there is potential in the future to add battery storage. And that's one of the things we're keeping in mind as we design the solar power system for the house. Okay, this is a question maybe you can start with, Dave. Jim Bates asks, can wood heating be green?
I believe it can, especially if you're cutting it off your own property. The carbon, it seems to be a carbon neutral. The tough part in an airtight house for wood heating is air quality in the building. So if you're going to put in a wood heater, go ahead, just make sure that you have outside air coming into the combustion box and not trying to get your combustion air from inside the building, because it's not going to happen. You just don't have enough air leakage through the building to support a wood fire of any kind.
Okay, good.
I do.
Yeah, most houses do. That's not a problem.
Yeah, I got that too in my 1900s house, as Dean Callahan does too. A question from Pete Giovannis. At the completion of the project, will the design, bill of materials, electrical plan, etc., be publicly available, or will it remain the property of the project sponsor? So we talked about this question a little bit, and I don't know all the answers yet, but we do believe that the students signed an agreement with the university that the university has ownership of this technology. So we need to learn a little bit more about that and see how we might be able to share that. So that's something we've thought about, but we don't have the answers. Here's a question from Dave Erickson. How do double stud walls compare to SIP panels? Or Sierra, maybe, I don't know. Either of you look at that?
Sure. So SIP panels, if you don't know, is structurally insulated panels. They're kind of like a sandwich of OSB sheathing and then usually foam insulation. And they typically come like pre-manufactured. You have to like order them, custom for your house. And since they do have a lot of high efficiency, good R value ratings. However, since they are so custom, and since there's typically a higher proportion of like foam extruded polystyrene products in there, they're a little bit less green than we were looking for, but the R values are probably pretty comparable and potentially even better in a thinner wall kind of structure.
Okay, good. Here's a question from Karen Lamore. Has anyone looked into codes, et cetera, for using a handheld hand operated lift? elevator instead of the ladder to get to the loft. Then thinking about my retirement years. I don't know, anybody want to take that one?
We build a grocery lift in a house using a garage door operator, but I doubt that would be code for lifting human beings.
Yeah.
I think even if you have an elevator, you still would need a stairway for fire or if the power went out. So it's difficult in a tiny house to find space for both.
Maybe a fire pole down the center of the elevator or something.
There you go.
Robert Anderson, what about costs as compared to conventional buildings?
I'll take a stab at it
Okay.
because I'm always asked this question. Right now, I'm seeing costs when we compare it to standard construction about 10 to 15% more.
And then,
But it's very tiny. So,
No, I'm talking about large houses as well. So over the spectrum of houses I build from 1,000 to about 2,000 square feet, we're looking at 10 to 15% more cost. The tiny house is probably a little bit more because we have so much wall to floor area.
Yeah.
but it's only, what was it, a 10 by 20? It's only 200 square feet.
yeah. So, I mean, I think Dave's saying the construction costs would proportionally maybe be a little bit higher in a tiny house just because you got less interior space per wall area.
So per square foot, it's a little bit more, but since it's so small, it's going to cost vastly less, I think.
Yeah, so that's a good point. I wanted to raise one other point about Dave's answer, though. It's also, once you consider use cost, you should make up that 15%, I would say, in probably a couple of years, right, Dave, in terms of return on investment?
Well, a couple of years is a little bit longer than that. I'm looking at probably 20 years to recover the cost.
Okay.
That incremental 10 or 15% more.
Yeah.
Okay. But again, it's still 200 square feet.
Yeah, so one of the things Dean Callahan's pointing out is that, as you all may know, lumber prices were crazy earlier this year. And that was exactly when I was buying some of the lumber for the house. But the thing that was comforting was it was a tiny house, right? And I didn't spend that much more on lumber because I didn't need that much lumber. So that was a nice hedge on the commodity market to have a tiny house and to have a large portion of it pre-built, right? Buying wood over the course of the academic year when most people aren't building, at least not in Houghton. So that worked out well.
Yeah, so this has been a really, really fascinating talk, and I'm gonna just thank everyone, and we'll stop recording in just a second, and then if anybody wants to stay on and answer more questions, we can. But as we end the recording, I just want to thank each person here. So we have a graduate, we have an undergraduate still here, we have an expert from the area, and we have Dr. Paul Sanders from Materials Science and Engineering. Thank you so much for your time. And I hope to see many of you next week on Husky Bites. And so we're going to go ahead and stop the recording, Sue. And so now we